next, I want to look at some connections among fraction concepts. And the two concepts I want to take on here are building fractions from unit fractions and patterns in division of fractions. So, building fractions from unit fractions. Well, unit fractions are a building block to both compose and decompose fractions. Recall that unit fractions are fractions with a numerator of 1. Therefore, whatever the denominator is, and recall, like I said before, the denominator tells us the size of the unit. The fraction represents one of these units. The concept of building quantities from a single unit began with whole numbers where we build from the ones unit. Now suppose we have an 8. So there's an 8. By using iteration, I can create more copies of this 8, and we can build 3 8s. Well, with fractions, we want students to see, that it's important for them to see that 3 8s is actually 3 1/8. And as students understand this, they're able to decompose fractions into pieces that represent this same total. Because now they can see, oh, well, I could do 3 of those 8s, 8 plus an 8 plus an 8. And I can actually write it differently. That's the same as an 8th plus 2 8s. And this is really important because this transitions to fractions that are greater than 1. So let's suppose we have 11 8s. Now we can say, oh, well, I could decompose that into 8 8s and 3 8s. And that would be the same as 1 plus 3 8s. So that's why 11 8s is the same as 1 and 3 8s. Now, patterns with division. This is the other topic I wanted to get. So that was units and how units play an important role. And now I want to talk about patterns with division. So I have to say, one of my favorite things to do in math with kids is to guide students to look for and identify patterns and to generalize from these patterns. I'm not just talking about fractions, I'm just talking about in general. And if you know your standards for mathematical practice, then you'll recognize this as part of the standards 7 and 8. Now, division with fractions, surprising to most people, actually lends itself well to this idea of looking for patterns to get to the algorithm. A beginning approach really is to move students toward the standard fraction division algorithm, invert and multiply, as you know it, is to use what students learned previously about dividing with some basic fractions to identify patterns that can be generalized. So we'll look at that first chart there, the table on the left, where we're dividing like 3 by 3. Well, 3 by 3, 3 divided by 3 is 1, 3 divided by 1 is 3. Now 3 divided by a half. Well, again, I could go back to the number line and count how many halves are in 3. And there'll be 6 of them. 3 divided by a third. I can count how many thirds will be in a 3. There'll be 9 of them. How many fourths in a 3? There's 12. How many fifths in a 3? I can count those on a number line. See, there's 15 of them. And how many fourths in a 4? There's 16. Now I can ask students to look for a pattern in their answers. Is there a shortcut we can find to doing this without having to count them on a number line each time? And hopefully, and with some guidance, we see that, hey, I could multiply the dividend, that whole number, by the denominator. By the denominator of the divisor. So if I multiply the whole number times that divisor, or the denominator, I get the answer. So they can write a rule for that. Whole number times the denominator gave me the answer. So there's just a very beginning rule to start with. Just the first step. Then we look at that second, the middle table, and we start again. So now we're going to do 3 divided by 4. We saw that was 12 already. Now 3 divided by 2/4. Again, I can go to a number line and count how many 2/4 are in 3 and see there are 6 of them. Then with 3 divided by 3/4, I can go and count how many 3/4 are in 3 and see there's 4 of them. I could do it again with 6 and see, okay, 6 divided by 1/4, there's 24 of those. By 2/4, there's 12 of those. By 3/4, there's 8 of those. And again, I asked students, look for a pattern here. Let's build off of that pattern we saw in the first table where we multiplied that dividend, that whole number, times the denominator. Then what happens? And we start to see, oh, when it was 1/4, we divided by, it was 12. When it was 2/4, it was 6. And then it was 3/4, it was 4. Start to see that relationship that we're taking that answer and dividing it by whatever the numerator is. So we get a new rule. Whole number times the denominator divided by the numerator gets us now another step closer. We look at that third table. 3 divided by 1/4, again, that's 12. Now we're going to keep the 1/4 the same, that divisor the same, and keep changing the dividend. 3/2 divided by 1/4. Again, I can look at that on a number line and identify and count exactly how many fourths are in 3/2. 3/4 divided by 1/4. On a number line, I can count that. There's 3 of them. 3/12 divided by 1/4. There's 1 of them. Now we look for a pattern here. And again, building off of that first pattern we saw, we take that 3, which in each case is there, multiply it times the denominator, gets us 12, and end up dividing that 12 by whatever the denominator of the dividend is. So students can write this as a rule. First numerator times the second denominator divided by the first denominator. Well, we're not quite there yet, but students actually can already now solve this problem. What is 4/5 divided by 1/8? And the key here is that we start to put this together. We can put those last 2 tables together and work with kids to get to the algorithm that for all fractions, we just invert and multiply is a nice shortcut to get there. But they've already done most of the work here, seen the pattern and made some sense of it. And it's worth mentioning that materials today also provide some mathematical arguments and properties and diagrams to help show how the fraction division algorithm can be derived through properties using both partitive and measurement division. And these methods, they're pretty complex in my view, and I've found them difficult for both teachers and students to make sense of. However, they do provide a valid mathematically structured justification for the invert and multiply algorithm. So I want you to know I'm not arguing against these or other approaches. I'm just showing what it is I like about the patterns approach. Not that it's the only approach to use, not the only approach I use. I mean, it's not the only thing I do with the division fractions. And it's nice to have students to begin to build to this algorithm by them identifying patterns in the math, and by the students creating valid mathematical rules for the patterns they see, and by guiding students to generalize this math. Certainly, there's still plenty of teacher guidance that is still important to bring the point home and to coalesce what students notice and describe into a final division algorithm. But I love how it's built on sense-making students do with the mathematics along the way. And this is instruction in my mind that teaches both content and process together for real mathematical proficiency.